So question number 6 on page 63 says the volume in cubic centimeters of an expandable gift box can be represented by the polynomial function Vx. So the volume of the box equals negative x cubed plus 35 x squared plus 200 x, and the height, I already know the height is 40 minus x, and assume the length is greater than width. Length greater than width. Obviously, the box, if like this, okay, so we should have the height. This is height 40 minus x, and then maybe the width is x and the length is something x plus something. So, but we're not sure yet, so we try to do the factoring, because the volume must be the product of length times width and height. So we try to factor this. It's easy, you can tell it's easy to factor the x. You got an x, negative x squared plus 35x plus 200. And this is the quadratic equation to factor. It's not difficult to factor them. But if you're not used to deal with the negative sign, you can factor the negative one outside. So you get actually the negative one coming in front of the x. You got a negative x. And then you get x squared minus 35x minus 200. If you do the factoring, you probably, because you figured already there's a term is 40 minus x, and because we take the x negative one out, this one must becomes like x minus 40, right? And then you can quickly guess the other one must be x plus 5, right? If you don't believe, just go back to see if you can get back to exactly the same thing. Now this time we can adjust. If you want, you can just adjust this to put the negative one into this term. We got x. Switch this. It doesn't matter. Just put let's just put an x plus 5 here, and this one, because you multiply negative 1 into this, so it becomes 40 minus x. Now it's clear now we have x and x plus 5 as the three, the length and the width, and because it says the length is greater than the width, so we must have the x as the width and then x plus 5 as the length. And why we got a 40 minus x as the height? So the question must be the three dimension length, width, height added together equals 40. So 40 centimeter, okay, is the sum of length, width, and height, right? So you can easily conclude that. So then we have a binomial for the length and the width. The width is actually just x, not really a binomial, right? So we finished the A. So that's the A we done. Okay, then B. B, we need to graph the function, sketch the graph. What do the x-intercepts represent? If you want to use technology, of course you can do that, but we just try to sketch. So we just quickly draw a coordinate system. So this is x, this is y. Now this one you can look at it here. So you can look at it this one, because this is more like a standard form. We always have x and x minus plus minus something, right? Like this one you have 40 minus x. You may not used to this, so just look at this. Okay, look at this. So we should have 3 zeros. The polynomial function, right? 3 0. 1 is 0. And look at x minus 40. You should have a 40. Right, this is 40. And this one should be negative 5. Negative 5 here. Negative 5. And then because this is a leading coefficient is negative 1, if you look at back, so this one negative 1. So when x is negative, so negative, after you cube it's still negative. So then this one become positive. So your graph should start from top and comes down and then goes top again. And then come down past the 40 points and then goes down forever, right? Coming from top. So the arrow just means you can go up forever, go down forever. Now of course that's the graph for this polynomial function. Because x has a meaning. X is the width of the box. So obviously we already analyzed that the 40 centimeter is total of length, width, and height. So obviously this polynomial function has a domain. So x must be greater than 0 and smaller than the 40, right? Otherwise you can't form a box. Okay, and obviously only this section of the graph is valid, from 0 to 40 for x. Okay. And then the B is really asking, sketch the graph, what do the x-intercepts represent? So we can interpret that 0 is actually the minimum. It actually cannot be 0. It have to be more than 0. So that's the number. 0 is the x must be greater than it. And then the 40 is x has to be less than this. And this negative 5 doesn't really have any meaning in this case. Okay, so that's B. And then the C. C is you need to determine what is the maximum value of this volume, maximum volume of the gift box. So finding V maximum. Okay, now obviously we're looking for this point. So when x equals this value, now we don't really need to find out this, but when you use graphing technology, you can find this same time as you find the volume. So change it a little bit. Okay. So and then this value on the y-axis, this should be the V maximum, right? So basically this is the point that we're looking for. Okay, so and then we go back to the GeoGebra. So we type in this function in, so you're already in, so negative x plus 5 and x minus 40. Okay, that's the way. Just another form. I factor the negative x out. So here you go. You get the same function as very similar to the one I sketched. Of course, so the maximum is not right in the middle. It's kind of shifted towards the right. Okay, to find out this, so for this particular software, they provide this function called extrema, extremum, not sure how to pronounce, and then you just need to figure out the function. That's f, plug in. So yeah, actually both points, local minimum, local maximum being found, so we don't need to worry about the a. It doesn't it's not meaningful to this question. So for the b, that's a number here, 25.91. That's x, so that's basically should be the width. And then 11, oh, this is a big number, 11284.37. That's gonna be the maximum volume. So Vmx equals 112, forgot, 84.37 cubic centimeter. Okay, of course this is a method I use the software, but you need to practice how to use a TI-83 plus graphing calculator. So we practiced in class, so I really encourage to get a graphing calculator by yourself so you can practice at home.